All right, here we are in video 2 of lesson 11, continuing to work on standard algorithm and multiplication. So as you can see, we have a problem on the board. What number is 111 times as much as 2,222? All right, so let's start by thinking about what does that mean, right? What expression can we use to represent this number? What number is 111 times? So there's a clue that it's going to be 111 times 2,222. All right, so now we know what our math problem is. Can we estimate what the answer would be? Think about an estimate for this answer. All right. Maybe you're just thinking, let's keep it easy. Let's think about 100 times 2,000, right? And hopefully that is easy for you now because you know about using zeros to multiply. So 1 times 2 is 2. And how many zeros do we see? We see 5 zeros. So we have 5 zeros there. 1, 2, 3, 4, and 5. So our answer is going to be about 200,000. We could be a little more specific and multiply 110 times 2,000, which would be 220,000, or 110 times 220,000, times 2,200, and that would be about 220,000 as well. So there's our estimate. Now we have to actually do the math. So 2,222. We're going to put that one on the top. Now, these are notes, right? And this is not in your book. So where could you write the notes? You could write it on the facing page of lesson 11, which would be page 93. So you could put it on page 90 or any blank page that you have in your book. Just make sure that you know where to find it so you can show me your notes from lesson 11. All right, because you are following along with me and writing these things down. Okay, so 2,222 times 111. So we have a lot of 2's and 1's here, so that makes our math a little bit easier. Let's choose green. 2 times 1 is 2. 2 times 1 is 2. 2 times 1 is 2. And 2 times 1 is 2. Right? So basically 1 times 2,222 is our first layer. Now we have to remember when we get to our next level that we have a magic 0. And guess what? We have the same thing again. So we could just say, I already know what 1 times 2,222 is, and just write it again. And then when we get to our hundreds, we have 2 zeros. We can remember that because 100 has 2 zeros in it. And then we can do it again. 2,222. All right, and then we're going to add those all up. 2 plus 2 is 4. 6, 6, 4, and 2. So 246,642. Fairly close to our estimate of 200,000, right? Okay, very good. Now let's think about the parts of the standard algorithm that we just worked on. We have 3 levels here, and each of those levels is called a partial product. And we have been working on this word quite a bit. It is a word that you do need to know. Partial means part, right? You see the word part right there, P-A-R-T. Okay, part of the product, and product is the answer of a multiplication problem, right? So each of these parts is a partial product, yes? So here's a partial product, here's a partial product, and here's a partial product because it's part of the answer, which is the product, okay? Make sure you know that vocabulary. That is very important. And we have another problem to do. Okay. I wish it didn't show us the whole thing right here. It would be nice if we just had the question. So I'm just going to write it for us right here. Clear that off. Okay, so our next problem is 4,603 times 507. All right. Or what is 507 times as much as 4,603? All right. So how are the factors of this 4-digit by 3-digit multiplication problem different from the factors of our previous problem here? Factors, numbers that are multiplied together to make a product, right? Factors, another important vocabulary word. So how are these two factors different from these two factors? Well, you might notice that we have 2 zeros here, and in this problem we have no zeros. Okay, and 4,603 is more than 2,222 and 507, so our factors are larger, right? And we don't have any repeated digits like we did over here. This was pretty nice with our repeated digits. Okay, so let's make an estimate of what would this be. I'm thinking about 5,000 times 500. Yeah, sorry, my 5's a little messy there. 5,000 times 500. Okay, and 5 times 5 is 25. Having trouble with my 5's today. Okay, and then 3, 4, 5 zeros. 1, 2, 3, 4, 5. That makes 2,500,000. Okay, so that is our estimate. Now we're going to work on the standard algorithm. And you know what? This is going to be number 1 in your Edpuzzle. So go ahead and work on that and put it in Edpuzzle. All right. Thank you for your hard work in Edpuzzle. And we can see here is a standard algorithm solving the problem. Let me see if I can get it all on the board for you. There we go. All right, check your work that you did and that you put into Edpuzzle. And if you made any mistakes, make sure that you understand what they were. You can always pause the video if you need to do that. Is the answer reasonable? Our estimate was 2,500,000. Definitely close to 2,500,000, right? Also, why are there 2 zeros here? I thought we only put 1 0 when we were in the tens place. Because we didn't do the tens place at all. We multiplied 500. So you could do the tens place and put all zeros. Maybe you did that in your work, but it's a lot of zeros, right? Really not necessary. It's only going to come out to 0. But when you go to the next level, you have to remember that you're in the hundreds now, and you need 2 zeros, okay? And that is also why there are only 2 partial products instead of 3 partial products, when here we're multiplying by 3 digits. So we should or could have 3 partial products, but because the 0 means nothing, we can just get away with 2. As long as you remember the 2 magic zeros here. Okay, very important. Thank you for your kind attention. I appreciate you so much, and I'll see you in the next video. Aloha.